Welcome, everybody. Now that we've digested our food from Thanksgiving, if you live in the United States, and you had that warm feeling back then with the fire, I find that coming back to the realities of the building industry is really chilling to my soul. So I thought that we would talk about it and talk about how we can use it as an opportunity for improvement. Because, of course, we all see things that are terrible. If you saw the most recent video on my YouTube channel, it's about a fan that was wired backwards at the factory before it's even delivered to the house. So we need to just be checking things because it's pretty cold out there when you actually get into the hard reality of things. So in case you don't know who I am, and I know that a lot of you I already know personally. So anyway, I've got more stuff out there. If you enjoy this, go ahead and check out my YouTube channel. Check out my radio show called The Building Forums Podcast. Those are both free. You can check out my book. You can preview much of it on the website, and you can get that through Bill at TrueTechTools.com. I've got a system for working. I use my own software, and I've been giving it to other people to use as well. It's called Apt Reports. And then we've also got the certification courses, BPI Exam Prep, HERS Rater Exam Prep. Those are up to date. BPI Exam Prep, I just went through some rigmarole with the new November release of the standards. And of course, every fall, I'm doing the fall fast track. So if you want to get really in-depth with this in a 6-week class and learn everything that I have to offer, then there's that. You can register for that for free just to get a spot in line at homeperformance.training. So, first of all, you know, maybe you don't, that I used to be a piano player. I used to hang out with ballerinas and modern dancers all day long. So when I got into the building industry, I thought for sure, like, I must be wrong. There is no way that grown-ups who are older than me, who have been doing this way longer than I have been in the industry, could be doing work that is this bad. And the thing that you need to realize is that you should think, am I wrong? And then immediately you should follow it with, well, let's find out for sure, and it's totally possible that I am not wrong. This is that bad. So let's all say the experts creed together. I want you to raise your right hand and repeat after me. Sometimes I am an idiot. Good. Now, if you didn't do that, you're going to feel sorry for that later. You're going to have to make that up at lunchtime. We should all be saying that every day because being an idiot is critical. First of all, that we realize it because we are all total idiots. Secondly, you need to be able to say that because it helps you relate to your clients better. People don't like experts who are know-it-alls. No one likes that. I don't like it. None of you like it. So let's all be the idiots that we are and admit it. And then let's go ahead and find out for sure who the real idiot in any one situation is. In this case, it's this house. This house is a total idiot. I saw this house last week. And my client is very nice, very sweet couple. They bought the house. They've got a little family. Moved in, immediately started having comfort problems, and that's the kind of stuff that I get called in on. So first thing you always need to do is house is a system, right? So we're doing a house as a system analysis. So first thing we need to do is think as a system. There are the 4, 3, 2, 1 that I'm always teaching. Let's blast through it right now. There are 4 elements to home performance. They are heat flow, airflow and pressure, moisture, and indoor air quality. If you want more of an explanation on this, go to my YouTube channel, and there's a video that's much more animated and much more in-depth about this. There are 3 improvements for every home. In order, they are always air sealing, insulation, and HVAC. When you say insulation and air sealing, people stop listening after you say insulation. So you never call it insulation and air sealing. Call it air sealing and insulation. And then they go, wait, what was the first thing that you said? When there are always 2 systems, and only 2 in a home. In a commercial space, this is totally different, but in homes, there is the enclosure and there is the engine. The enclosure is also called the envelope, and the engine is also called the HVAC, anything that creates or moves heat or air inside the building or between inside and outside. That includes things like bath fans. That includes things like water heaters, etc., etc. And of course, there is all of this is called home performance because there is only one goal, and the goal is control. The goal is not energy efficiency. I say that all the time. I say that on a monthly webinar. I say it in my book. I say it on my videos. And people still don't get this. your clients are not interested in energy savings. Your clients are interested in high quality life. And in fact, they're not even interested in home performance. They're interested in a home performance experience. And the number one way that you prove that you have control and give them that home performance experience is performance testing. Performance testing is not an aspect of performance contracting. If you are in the performance field, the home performance or the building performance field, performance testing is the only thing that differentiates you from a normal schmo. So we need to make sure that this happens all the time. Now that we've got the thinking as a system, we need to act as a system in the house, because otherwise we spend 8 hours in every house and it's just really, really inefficient. So the first thing you always do is inspect. You look with your eyes, you smell with your nose, listen. The second thing you always do is whip out your tools and you start doing diagnostics. Then and only then you make recommendations, and then you make improvements, or in my case, I don't make improvements, my contractor affiliates do. At which point, always, always, always more testing to prove that the client got what they paid for. Once your clients understand that they can have proof that they got what they paid for, they will never pay for someone who does not prove it again. Never. All we have to do at this point is teach homeowners that they can expect proof of purchase. Okay, so step one is, repeat after me, inspection, right? So we always look at the house. Now this house is shaped like this. We got a big old vaulted ceiling. We got 3 skylights. We've got this mystery room over their bathroom that they didn't even know they had until I pointed out, like, oh, look at the ceiling, it's shaped like this and your roof is shaped like that. That means there's a room in there. That's a little attic. There's an addition at the back that's a kind of an attic space over it as well. So let's go ahead and look at this. Now I'm going to just start blasting through this. First thing that I see when I go into the house, we always start at the bottom, go to the top. That way if there's an attic, I can get up into the attic hatch. This thing is in the basement. What room am I in right now? And hopefully you're saying to yourself, well, there's, let's see, a tile floor. We got some like waterproofing smudge on the wall back there. Probably this isn't a room that they look at a lot. Probably this room with this giant round duct that clearly is coming from outside, since it's dumping this 56-degree air into the room, is the furnace room. This furnace room has a natural draft water heater in it and a sealed combustion furnace. Now these two things do need combustion air. The sealed combustion furnace gets it from outside. The water heater gets it through the louvered door that leads to the house. So whenever I see this in a house, first bells start going off in my head. I realize, uh-oh, somebody didn't know what they were doing when they were putting this house together. I have only been doing this for 6 years. I have never built a house. That will change probably pretty soon. But the first thing I always think as somebody who's 35 and doing this 6 years is, oh, wait, maybe somebody had a perfectly good reason for doing that. And you guys all think about this. You all have been in homes. You're all looking at stuff. Trust your gut. You see something and you think, maybe that's not necessary. If you have the diagnostics to show that it's not necessary, and what we do is just tape this up when we proceed with our testing, find out what it's like if it's not even there. Then you know for a fact. So my superpower is this. I've got a $4,500 infrared camera. You do not need a $20,000 infrared camera. I don't even know if those exist anymore. You need to go to Bill and you need to ask him, what is the best camera for my needs? In my opinion, pay at least $4,000 for one, because the lower grade ones don't have picture-in-picture, which is what I'm going to be showing you today. Also, you're going to have to deal with the fact that people will think that your information is fake. Also, it's really easy to use this thing well, but it's also really easy to use it horribly. So all of the pictures I'm going to show you today are taken while the blower door is running in depressurization mode on a 30 to 35 degree day. So you need to make sure that you know how to use the infrared camera. That being said, I am not infrared thermography certified in any level whatsoever. I have been using this for 5 years and I know my camera pretty well. So what I'm going to show you today is a bunch of pictures that I took with my midline camera in my midline normal client's home to show them, to help them understand their story and to help them understand their home performance plan, which is what I offer. So This thing is sexy. You need to use infrared because it's going to get your client's attention. Also, the palette that I use is called Iron Bow. I use that for a very explicit purpose, and you can find more about that at my training portal, which you can get access to through buildingperformanceworkshop.com. Okay, so let's get into it. First of all, you start looking around. You're looking in the basement, checking out the wall insulation. And at this point, actually, the blower door is not running because I like to do a conductive scan at the beginning. You can start to notice that there are some places where the insulation is not awesome. Now, you always need to do an analysis here, right? Warm to cold. That's the way that heat moves. Heat moves from where it's hot to where it's cold. So it's outside this basement wall, it's 55 degrees in the ground. Inside, it's always warmer than 55 degrees. So heat is going out. It's going out faster through the cavities or through the studs. It's going out faster through the studs because the studs are cold. So that means they're sucking the heat faster. So this wall appears to be insulated. And what you say is always, it appears to be that this wall is insulated. Also, we're looking at a qualitative analysis, not a quantitative. So I do not care as much about the numbers that you're seeing in the bottom there. I'm caring about the quality of one thing compared to another thing. So you can see in the bottom left cavity, there's a little insulation problem. In the top right cavity, it's not so much of a problem. So that quality shows me that there is insulation in there, but it's not installed perfectly well, as we can see when we walk throughout the rest of the basement here. Okay, now that might be with craft facing on it. You can see in the top there, we've got these little punch-out things. That might be where somebody really tapped it in to make sure that it would sit nice and tight in that cavity, because it's friction fit. So anyway, we're seeing all this stuff. It's good to know that the walls are insulated. Not so great to know that they're not insulated perfectly. First thing that we see when we go on the first floor, and now the blower door certainly is running, is that we've got a mail slot. Mail slots, not good. Mailbox, always better. So the mail slot is a thing. Also, this is in a closet. That's the coat closet in the front of the house. Client complains that this coat closet is cold. I'm sure that you've heard this before. We have these two things in the coat closet. We've got a mail slot. We got a fixture. The fixture clearly is leaking air into the house, although most of the time, because of stack effect in the wintertime, we're leaking air out of it into the attic. That means that the closet becomes depressurized. It sucks air in from the mail slot, and there is no heating register in here, so it's going to cool down. That's a normal effect of having a room that does not have a heating source in it, that the door stays closed most of the time. So there is no fix for this closet, except for the fact that we could seal up the mail slot, but still this room is going to be colder than other rooms. So also, it happens to be located right next to this, which is our front door. The door itself, obviously, not super insulated. It's got these cutouts in it. But the main problem with this door is not the door itself, as you can see around it. The main problem with this door is the way that it was installed. It was installed by a monkey. So yes, builders really can be doing this type of work. And this isn't necessarily personally at some one person, but we all need to realize that we don't think all the time. And sometimes we cut corners because we think it's okay, and sometimes we cut corners again and again and again and again because it becomes habit to us. So we need to make sure that this stuff does not happen. This is all easily fixable. You do not need to replace the door. Now, over the front door, we have one of these little attic spaces that doesn't line up with the roof lining, right? So we've got this vaulted ceiling in most of the building, but here we've got this little tiny attic space. They didn't even think about that they've got this. So when you back up, you start to see, oh boy. Now, this is a vaulted ceiling. We looked at this before the blower door was running, and it didn't look quite this bad. So we saw that it was an insulation issue, but also, bigger deal, is it's an insulation and an air sealing issue. And the air sealing is always going to be a bigger issue than the insulation. So we've got a major issue with the ceiling. As you can see, absurdly, the only insulation that is acting like it should is in the cavities where the skylights are. So that's kind of fun. All the rest of them are not at all insulated. So essentially, even if there is insulation in there, it's not doing what it wants to do. You can see that this is an endemic problem to the entire ceiling of this entire giant great room, which is the main problem that they're having with the house, is that this room is just freaking cold all the time. And you can see that it gets worse and worse as you turn around. So we can notice that there are problems that are embedded in the roof cavity. This is definitely fixable if you have an injection process, and you should make sure that if you don't have one, you have an affiliate who's got one, and I certainly have people on my list. Now, I was called out here specifically because this guy had been calling window replacement people for a couple weeks, And he got these bids for, somewhere probably between $10,000 and $30,000 for replacing all the windows, depending on the quality. And of course, don't trust any billboard that says that you can have professional quality at do-it-yourself prices, because that is exactly what he already has. He has windows that are actually fine. They are mid-grade windows. Going from a mid-grade window to a high-grade window is a drop in the bucket, because really the main problem is that we've got this cistern of energy leakage that is resulting in performance problems for the house. I'm not talking about energy efficiency again, I'm talking about comfort. These windows are installed terribly. So replacing the windows is actually not the answer. The answer is the windows are fine, it's the way that they were installed, right? So explaining this to your client is really the key, and showing them a picture that shows them that the window itself is not the problem, it's where it's installed is a much bigger deal. So we continue moving on with the rest of the ceiling, and we can see that, again, endemic problems. We've got all kinds of really strange put together. This thing that you're seeing in the middle there, the purple, is a pipe that looks like a gas pipe. It may also be a really, really tiny sewer stack. Really strange. All of this stuff points to, at some level, a contractor who lived here who did his own rehabs. So interesting. A lot of people think that if they buy a house from a contractor, it would be better. But in fact, it's not as good. When we do inject this stuff into the ceiling, we're going to have to watch out for these recessed can lights. And what I would recommend for them at this point is just the LED retrofits that are airtight, caulk around the trim there, bam, you're done. Now, when we move into the addition, we can see clearly here, that is a picture of, and you should be checking this out for yourself right now, is a picture of top plate leakage. So top plate leakage, big deal, especially where additions connect with the main body of the house. Any place that you see that's got an addition, most likely you're going to see this problem, because they do not think very well about how to attach. It's like Frankenstein, right? You need to attach the arm to the torso pretty well. They're not thinking like that. They're thinking about erecting a whole separate little house next to it, and they just kind of connect them. So we've got top plate leakage pretty majorly all over the place. And we can see also that we've got this trim work at the top that's a very nice little, patterned thing, and it's fine and dandy, except for the fact that the drywall behind it does not actually connect. So we've got air leaking out of the roof cavity into the room behind the trim. Now, in the interior walls, we also have top plate leakage. So that's an exterior wall, but over here on the right is an interior wall. And in fact, here is something that you might not think looks immediately like top plate leakage. We've got a baby's crib in front of us. We're obviously in a bedroom. We've got this big, potentially wet spot, that's what I would think if I hadn't spent some time scanning the house in the beginning to make sure that I knew where all the wet spots were before we started seeing air leakage only, because of course, as soon as you run the blower door, the air leakage is going to drown out all other noise in the house. You will not see anything except air leakage when the blower door is running on a day like this. I turn the corner and go into the room next door and look up at the top, and I can see clearly on the right, you see the mirror, you see the light fixture. Where are we? Bathroom. There is a toilet underneath this. So of course, that thing that's causing this is the plumbing stack. And you can see it clearly enough that actually there is an outlet in the middle of that wall cavity that's leaking air around it, and it's positioned above the toilet there. So this is a big enough deal now. I could just pressure pan that wall outlet and find out for sure if I didn't have an infrared camera. And if you don't have $4,000 to spare, I can totally understand that. But you could pressure pan this, and you can do all of the diagnostics that we're doing right now without doing infrared. Infrared is sexier, and you will win more clients through it. So, in addition, in this bathroom, we have this. This is missing insulation. Missing insulation over the shower is the worst place to miss insulation, so make sure that you haven't done that. Do we need to pause and take any questions at this point? I'm talking like a mile a minute.
I'm not getting any questions.
Good.
Nope. People are just absorbing.
Fantastic.
Take a breath, though, dude.
All right, keep absorbing. I'm gonna drink some coffee.
All right. He needs to drink coffee, right?
I need to drink coffee. Somebody give me some. I would booze it up, but I'm not a drinker. So let's see here. Okay, so we've got continuing the addition, also same quality as the main body of the house, and all of this was rehabbed in the 90s, right? So just because a house is new or has new features or anything like that, you need to make sure that your clients, and if you are not a professional and you're listening to this, please understand for yourself that just because something is new does not mean it is good. or any better than something that is 100 years old, because I have plenty of clients who have 100-year-old homes who perform way better than this home that is shiny and renovated and all that stuff. Sliding glass doors, are they a problem? Should we replace them? No. Why? All sliding glass doors look exactly like this. Sliding glass doors suck, air leakage wise. They are just the worst. So if you're going to have sliding glass doors, especially a whole wall full of them, you just have to deal with it. And we're back to the windows again. Everywhere I look in the house, I'm seeing the same pattern. The windows themselves, not a problem. Where they are installed and the manner in which they are installed, totally the problem. So essentially what I do in my report is I take 3 pictures of windows and I say, client, all of your windows look exactly like this, and this is the problem. I do not fill up my report with 1,000,000 pictures of their windows, because that is exactly what they were expecting. And part of my job as the magician who comes in and does the building forensics to solve their problem magically is to show them things that they had no idea even existed, like top plates, like interior walls, like plumbing stacks. So here we can see again, trim, big problems, very pretty, good for real estate, good for appraisals, terrible for performance, unless you have tested it and you know for a fact that it is not. We have interior wall top plate leakage. We've got insulation problems in the flat ceiling portions. So we can see that all of this stuff is becoming a major problem. They do not need to replace their windows. In fact, what I want to point out to you in this picture is if you can hone in on the very corner of the wall where the ceiling intersects with the wall, you can see a little soffit there. Now, any place where you see extra corners where there should not be extra corners, that means that they're hiding something. And it really is that bad. So in this case, we've got this little soffitted in jot for about 3 inches, and then it goes up and it connects with the vaulted ceiling, and then it continues from there. As you can see in all of these pictures, that thing is connected to the roof eaves. So it's got a lot of air leakage to outside. That means the top plate in those walls definitely not acting like it should. It means that the roof insulation not going to be able to act like it should because it's got so much connectedness to the outside. Knee walls, obviously a big issue. Some of them, not so much. Some of them, definitely. We need to fix wherever it is a problem because, of course, we've got the assembly U-value calculation, and we know exactly what that means. And if you don't know what that means, go into my training portal, and I talk at length about that kind of stuff. This picture is one of the last that I'll show you, and I just want to point out that when you are running the blower door in depressurization mode, and you have a duct that's on an exterior wall, you can take a picture and see exactly what temperature the interior of that duct is. Now, if I was just running the heating 10 minutes ago before I started my blower door test for my combustion testing, then why on earth would that supply duct be 62 degrees? It's probably because it's in an exterior wall, as you can see the window above it, and it's got air leakage to the outside through the exterior sheathing. So all this stuff means that we need to use more testing. You need to be able to show people that you cannot hide anything in homes anymore. All of this is important. Proof is possible. Please stop guessing. Make sure that your clients know that they can stop guessing. And I'll go ahead and stop and take questions at this point.
Okay, I'm not seeing any questions come in right now. I do want to mention just one sort of technical fact about thermal imaging.
Okay, yeah.
The thermal imagers measure surface temperatures. So when Corbett was showing shots of like air vents and things like that, he was actually showing the impact of the air temperature coming through the duct, hitting the surfaces, and then measuring that surface temperature. So just kind of a little nuance here. You want to make sure you don't ever say that you're measuring air temperature because that can easily be debunked because you cannot measure the temperature of air with a thermal imager. It measures surface temperature. And then the other thing too, like if you've looked at a lot of these, and I know Corbett knows this fact, but you are not seeing through the material, but you're seeing the heat pattern that's projecting to the surface of the material due to what's happening behind the surface. So even though it looks kind of like you're seeing the bones of the house coming through, you're actually seeing the thermal map of what's happening on the surface due to the heat pattern behind the surface.
Yeah, definitely not an X-ray. And Bill knows because he's helped to design these tools before. But you need to just use it as much as possible. That's the main training that you can use. You talk about it, use it, understand all of what Bill is talking about. And by the way, a lot of people will say, oh, well, what about just an infrared thermometer, like $50 at Home Depot versus my $4,000 camera? Bill, will you please explain to us the difference between an infrared thermometer and an infrared camera?
Sure. Sure. The infrared thermometer has basically one picture element, one pixel, and it's looking at a projected area that may be inches to actually feet in diameter on the wall. So it's going to absorb all that thermal energy and relate it back to one numeric value in the infrared thermometer. So it'll give you a good gross number, but it's an average over a whole surface. Now, compare that to a thermal imager where you have many little eyes, little picture elements, from hundreds to thousands to tens of thousands. And I'm thinking the camera Corbett probably has about 20,000 picture elements in it. So it takes each one of those little picture elements and it can paint a thermal map of what's going on the surface. And now you have some intelligence as to what's going on behind it. You have a heat map that's drawn that can show you what's going on in the material rather than just saying this is at an average temperature. The other thing is if you use an infrared thermometer, sometimes they're called infrared guns, they do have sometimes a laser pointer in it. That shows you the center of the target area. Now, it's actually, you have to read the instructions, God forbid, and actually look and see what the optics ratio is for the device. So if you have a 10-to-1 optics ratio and you're 10 feet back from the surface, it's going to be reading a 1-foot diameter circle that's centered about that laser dot. The laser is only a locating device. It is not the point of measurement. That's the center of the circle. And again, if it's 10-to-1 and you're standing 10 feet back, you're looking at a 1-foot diameter radius on the wall. So that's a fairly large area, not an awful lot of refinement to the information when you're using an infrared gun. They're good for certain things, but not good for others.
Knowing like these tools, and you could spend days on TrueTech Tools website looking at all the different types of tools you could have. Obviously, you want to use selective. You want to make educated decisions when you're investing in tools. However, any tool is only as good as you are because you are the one that's using it. And if you are able to rely on somebody, which is why I team up with Bill all the time, because he knows all of the back end about this stuff, then you are able to get better information with that tool because you could spend $4,000 on a tool, and I know plenty of people who do this, and use it like it's a $50 infrared. They don't take any pictures, they don't show it to their clients, they don't really analyze the pictures. So make sure that you actually do read the instructions, and like Bill said, God forbid, like a lot of the instruction manuals are not the greatest, and I will be the first one to point that out. But you can certainly watch tons of videos, and I've got them. TrueTech Tools has got them. Bill's made plenty of videos. Jim Bergman, his previous partner, has all kinds of videos. So make sure that you're just out there absorbing as much as you can about the tools that you do use, because that stuff really will make the difference.
Yes. We do have a couple questions here. Actually, same question from two people. What fixes do you recommend? And can you share the list of the recommended measures?
Yes. 4, 3, 2, 1 home performance. There are 4 elements: heat flow, airflow, pressure, moisture, air quality. You always look in terms of those. There are 3 recommendations I always make: air sealing, insulation, HVAC, in that order. So the fact that a room is cold means, first of all, probably, and in this case, absolutely, without any doubt in my mind, needs air sealing. And in fact, the blower door shows that it's more than twice as leaky as a house that was built to the minimum state code in Illinois would have to be. So absolutely, air leakage is a problem, so air sealing is the #1 opportunity. If I went in and just installed a bunch of insulation, if I blew in dense packed insulation into the ceiling, that would actually create the biggest problem for this home that it's ever encountered, because you'd still have air leaking into the roof cavity, and that would lead to condensation now, because I made the far side of the roof sandwich, the exterior sheathing, colder. So I would have all kinds of mold growing in my house, and we made tons of mistakes with this back in the 90s and the early 2000s. So make sure that you are absolutely tackling air leakage first, then insulation, then and only then we tackle HVAC. And it really is that simple. I know that some of you are being like, well, but specifically, how are you doing that? And that's exactly what you need to get out there and be doing. When I first got into this, and I'm just going to take a second to digress. When I first got into this, like I said, I was a piano player. I didn't know what a truss was. I didn't know what a plenum was. So I assumed that everybody knew what they were doing. Also, I didn't have the right training. when I got into it. I trained as a HERS rater for a week, passed the exam, and then started working in existing homes, doing essentially what I have come to understand is building forensics, to try and solve people's problems. There are two main issues with this that you will come across. Number one, BPI and ResNet want you to follow a very specific list that they have put together of things that comprise an energy audit. In the first place, you are not there to solve energy problems because hardly anyone actually cares about that. If they do, they will be explicit with you about it and they'll say, I want to lower my energy bills. Great, fantastic, we can do that for them. We will also give them the more important benefits of durability, air quality, comfort, all that stuff. So secondly, that energy audit has a bunch of things that are prescriptive. You're going to do combustion analysis. You're going to do a blow order test. You're going to do blah, 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 this and this and this. And you do these steps and in this order just like you did on your BPI exam or on your resident exam. If you do that, you are not solving people's performance problems. You are executing a prescriptive recipe for every home exactly the same. I do not follow a prescriptive recipe anymore, and I found that that is the secret to me being able to charge rates that many of you would think are impossible in your local markets. And it's because I am not following a recipe that someone else has come up with. I have enough experience with these tools and using them to help people pinpoint their problems and then prove that they got what they paid for and that the problem has been solved, that you can start customizing everything. It makes your life so much easier. You can walk into a home and really start to use a more educated eye towards this stuff. So I would say definitely just be out there using it. The specifics of how to exactly solve these problems will come to you once you realize exactly what the problems are and you see the evolution of the problem from one house to another and in one house before and after a fix. So be teaming up with contractors. If you're not one already and you're trying to do all things for all people at once, definitely just team up with somebody who's already doing the work, test their work, and see how that work is doing. And then you'll know better how to scientifically start approaching this.
Okay. I haven't seen any other questions come in. So one person raised their hand, but it's best if you type the question. So,
Bill, do you want to show us the some stuff at TrueTech?
Sure.
For a minute.
Let me grab the screen back from you. Okay, so as Corbin mentioned, here's